Hello everyone, welcome back to the Literacy Volunteers of Harrison County YouTube channel. We would love for you to subscribe to our channel. Just click the bell icon below and hit subscribe and you'll be notified whenever we put out videos. I'm going to do a couple videos today. You can watch them one and then the other. I recommend the one on simple machines first. They're basics physics like you would have in maybe 9th or 10th grade. So we're going to look at simple machines and what they do. The purpose of a simple machine is to make work easier. Right? They don't have very many or any at all moving parts, and they work by changing the direction of the force or the amount of force we need to do something. They do not change the total amount of work needed to perform the overall task. So what we need to define first are the two words force and work, how they relate to physics, right? So a force is a push or pull upon an object resulting from the object's interaction with another object. That's a force. Whenever there is an interaction between two objects, there is a force upon each of the objects. So if I would take my hand here and place it and push against the wall, I'm pushing with a force against the wall, but the wall's pushing back against my hand with the same amount of force. If not, one of us would move, right? So there's an equal amount of force. Those are what are called contact forces, right? We have two interacting objects. In this case, it's my hand and the wall, and they are perceived to be physically contacting each other, which we are, when I push against the wall. I drew a little picture for you up here. This is just a table and a box sitting on a table. And a book, rather, sitting on a table. The book is exerting a force on the table. So here we have the book. Here's the force arrow going down, right? But in order for this book to remain on this table is pushing back up with the same amount of force on the book. So we have the force of the book on the table and the force of the table on the book. Also, we have the force of the table on the floor and the force of the floor on the table. Those are all of the forces in our diagram here. Force is measured in what we call newtons, like Sir Isaac Newton. And a newton is the amount of force required. We're going to give a 1 kilogram mass an acceleration of 1 meter per second squared. 1 meter per second per second. So 1 newton is equal to 1 kilogram times meter per second, right? That's what 1 newton of force is. What we want to look at force is it's a vector quantity. We have vector quantities, scalar quantities. Vector means it has both a direction and it has a magnitude. So we would say that's a force of 10 newtons down, right? Or a force of 20 newtons up. A vector means we have to talk about both of those things. When a force acts upon an object to cause displacement, that means it's moving, right, of that object, it is said that work was done upon that object. So once we set that force to move something, now we're doing work. The three key ingredients for work, we have to first have that force, then we have to have that displacement, that movement, then we have to talk about what caused that object to move. Okay? So let's look here. We have this little guy. I drew him. I'm not the best artist. He's got his little hat on and he's at the grocery store. Here's his grocery cart and he's pushing the grocery cart. See, the man is exerting a force once he pushes the cart, but the cart is being displaced, right? It's moving across the floor. So we have this man pushing the grocery cart this way, and the forces are moving the wheels. The wheels are exerting a force down onto the ground. The ground is exerting a force up onto the wheels, but he has to overcome this force in order to get that cart to move, right? So work, that's the work he's doing on the cart, can be calculated with this equation. Work is force times distance. So if we wanted to measure how much work he's doing on that cart, we could say he's pushing with a force of 10 newtons over 10 meters, right? So we take those and multiply them. 10 times 10 is 100, and the unit for work is called a joule. Joule. That's the amount of work that is done when 1 newton of force moves an object over the distance of 1 meter. So that's our joule. So we would say that would be 100 joules of work. So now that we know about work and force, we can look at the 6 simple machines to see how they work. So we have this pulley, if you've ever seen a pulley, and there's a rope going up over this pulley. This is our hand pulling on the rope, and this is some kind of weight attached to the other end of the rope. So a pulley has a wheel that allows you to change the direction of the force, and as we pull down on the rope, the wheel turns, and what is ever attached to this rope goes up, right? This is to help would it be easier for you to go lift this heavy object up off of the floor? Or would it be easier to use the pulley and the wheel to change the direction of the force and to make you be able to lift it? You could lift a lot more, right? You're still doing the same amount of work. If this was 10 kilograms and we moved it 10 meters, it's the same amount of work, but we've changed the force that you have to apply to do that work, right? That's number one. Number two is a lever, right? This is a rock, maybe we have here, and we have this lever. This is called the fulcrum that it rotates across, and someone's hand pushing down to push the rock up. So a lever helps you move heavy objects. When we push down on one side of the lever, the other side goes up. If you're ever out on the playground and you have a friend and you get on a seesaw, one of you's on one end and one of you's on the other, and you have to push down to get them to go up, and they have to push down to get you to go up, right? So that's like a lever. The third type of simple machine is called a wedge. This is a log, and we're going to split this log with this wedge, correct? It's used to split materials. We're just using a log. By placing the thin edge, because it comes into a point, onto the log, we can hit it with a hammer, and the wedge will change the direction of the force and push that log apart. That's how you split wood, right? Or you have it on, it's already on the stick and you hit it with a force, right? The fourth type of simple machine is an inclined plane. It's easier to move heavy things up a ramp than it is to lift them straight up. So a ramp is a common example of an inclined plane. Here we have a barrel, or we have some kind of thing that we're going to move, and we're going to roll it up this inclined plane, which would be much easier for us than lifting it straight up off of the floor. The fifth type of simple machine is the screw, and we've all seen those, whether it's in your TV or in your furniture or wherever. A screw is an inclined plane, right, which would be this way, around a cylinder. So we're moving our inclined plane around a cylinder. The closer the threads are, the greater the mechanical advantage, and we're going to look at what the mechanical advantage is at the end. It is easier to drive a screw into an object if the thread spacing is smaller. So the closer they are together, the easier it is to screw that into the object. The last simple machine we have are the wheel and axle. So I drew sort of an axle here connecting these two wheels. They're two connected rings, right, or cylinders, one inside of the other, and they both turn in the same direction around a center point, like on your car. They may increase or decrease the input force, right, depending on whether the input force is applied to the axle or to the wheel. So here would be if the force is applied here, anywhere along here, or if the force is applied to either of the wheels, right? So those are the 6 simple machines. The last thing we want to look at the fact that all simple machines change the force by changing the direction or the distance over which the force must be applied, right? The work done is always force times distance. And this must always be the same because of the law of conservation of energy. In the second video, we're going to look at energy. But law of conservation of energy means energy can neither be created or destroyed, right? So we can't create energy in our work. So we're either going to have to change it by changing the force or changing the distance. And that's what simple machines do. Then we look at what's called mechanical advantage, and that's just a ratio of how much force we output to how much we have to input into this system. How much do we get out of that simple machine according to how much do we have to put in? Or why would we use a simple machine? Why would we not just do the work? There has to be some advantage to using a simple machine, right? So despite the changing forces that are applied, the conservation of energy is still true, and our output's going to equal our input. Essentially, the advantage gained by the use of the machine is transmitting the force specifically